This is the walkthrough video for PCTC 2022, round 2, question 7, binary grid wrap driver. So in this question, we're given this racetrack, and we essentially need to make this car or the hashtag go through the racetrack and basically print off the final state once it's finished going through the racetrack. And we have to adhere to all of the rules that it tells us. So my solution is probably going to be not necessarily the small or the shortest solution or the cleanest solution, but it's a solution where every single line of code makes sense, unlike some of them. So hopefully you can understand this quite well. So always the first thing to do is take in our input. So the way we're going to do this is let's create an empty list called track, and then we're going to take in a new input 6 times because there are 6 rows of our track. So let's say row is going to be input, and we want to add that to track. And so now track will be a list of 6 strings. Each string will be one of these rows. But one thing we want to do is we want to identify where the hashtag initially begins off at, because we need to know the starting coordinates. So let's say if hashtag is in our row, then we need to figure out where in the row it is, and we can do that just by doing row.index hashtag. And let's save that as that's current. So this is going to be our current position, and because we're at the start, let's call it pause actually. And because we're at the start of our code, the position is starting off at wherever our hashtag initially is. And we want our position to be a 2D coordinate. So right now it's just the index within the row. So to turn that into a 2D coordinate, let's also add in I. And that. So now what we have is, once this code is run, we should have a position variable, which is just a tuple, where the first one is the y coordinate and the second one is the x coordinate of where we start off at. But one thing, actually no, that should be good. Okay, so now we've taken our input and formatted it, we should get into the actual coding itself. Now the algorithm we're going to use is somewhat similar to a BFS or breadth first search, if you come across that. We're going to be using a simpler idea of a BFS, which basically means we're going to be going through each of our coordinates, checking all of the 4 cells around us, like the top, left, right, and bottom, including this wraparound feature. So we're going to check all 4 directly adjacent cells, and if that cell is firstly a 0, which means it's a track, and if it's also not a cell you've already been to, then we're going to move into it. So we need to keep track of the cells we've already been to. So let's create a visited set. Let's just call it viz. And the reason we need to do that is because we can't visit a 0 more than once, essentially. Because if you imagine, as we run the code here, let's say our code may, for example, say the next step is to go to this 0. And then once we're at that 0, then our code might be like, oh, look, there's a 0 to the left of it. Let's go back to the left. And this way, we might just be stuck in an infinite loop where we're moving our race car or our hashtag between these 2 zeros. So we need to ensure that we never visit the same 0 again. Zoom out a little. Okay. So our loop is going to be an infinite while loop because we're going to keep running this code until we've reached the end of the track. And actually, before we do all of that, yeah, that should be fine actually. So we're going to take in our pos and we're going to assign it y and x variables like that. So what we've done is we've unpacked our pos tuple, and that just means we now have a y and x variable representing our current position. And now what we're going to do is we're going to check all 4 adjacent cells. So to do that, and this is the way I like to do it. It's not necessarily the cleanest looking way, but it's the way that you can apply to basically every single question that has a grid. So if you remember how to apply this code, then you can apply it to so many different problems without really having to think about it too much. So that's why I use it. So let's do for yy in range y-1 and y+2. And for xx in range x-1, x+2. And so what these nested for loops do is we're now going to go through all 9 coordinates that exist around our cell coordinates. So for example, if our starting position is this hashtag, these 2 for loops, they're going to iterate through this cell, 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 this cell. So they iterate through all 8 of our adjacent cells. So those are the 4 directly adjacent cells, the 4 diagonal cells, and our current cell itself. And obviously we don't want to go through all 9 of those cells. you're going to want to go through 4 of them. And so let's just weed out the other 5 that we don't want. So what are the conditions of the cells that we do want? Well, if our cell is not the same thing as our current cell, so if YYXX does not equal YYXX, and this is just an easy way of checking if our coordinates are the same by putting them both into a tuple and checking if they're the same. So if they're not the same, and before we move on, actually, let's clarify. So YY and XX represent the 2 new Y coordinates and the new X coordinates. And we're just looping through all possibilities to find the correct possibility. Okay, so if our new coordinate does not equal, our old coordinate, or I guess our current coordinate, and we also want to make sure it's not a diagonal. So if it's not a diagonal if one of the coordinates is the same. So if Y is the same as our current one, or new X is the same as our current X. And I think that's all we need to check, because this time we read it out the 4 diagonals and our cell itself, which means we're left with just the 4 directly adjacent cells. Okay, and at this point, now we want to apply our real conditions. So we want to check if, what's our track? So it's called track. So if track YX is equal to 0, and, let's not capitalize that, and YX not in viz. So this basically says if the cell we're checking is part of the track, and if it's part of the track that we've not visited before, then we want to essentially move on to that piece of track. So let's update our position to be equal to YYXX. And let's just make sure we use the correct ones here. So YY and XX are our new coordinates, and Y and X are our current coordinates. Okay, so here we found a valid coordinate to go to, and that's why we updated pos, and let's also add pos to visited, just so that we know we can't revisit this cell again. And whilst we're at it, we should also, so this is our visited set, we should also add pos to that. And so let's just do that. And so what I've done here is visited is now our set, and it's a set containing pos, which is just the tuple of our current coordinates at the start. And we keep adding our coordinates to the visited set. Okay, you might now see a couple issues with this. For example, let's say the car is right there. Well, our code is now going to try and check this cell, this cell, this cell, and the cell to the left of it. And then I might get slightly confused. Or I guess a better example is if it checks the cell to the right of it. So let's say we're here. We don't want our code to check the cell to the right. Like the cell to the right doesn't exist, because Python will think that our cell to the right is at index 6, but index 6 does not exist. So if we're ever at index 6, we want to wrap around back to index 0. So we want to wrap around back to this and check if that's 0, because of what the description said. And an easy way to do that, whilst keeping all of this code the same, is just to apply the modulus function. So we're going to say our new x coordinate is going to be equal to itself, but modded by 6, and same for our y. And what this does is it just changes the coordinates so that if they ever say 6, which is an invalid index, then it's going to throw it back to 0, which is a valid index, and it's the correct index that we want to check. And equally, what it also does is if our coordinate is -1, it wraps it back around to the end, which is 5. I don't think that matters in this case, but that's one thing it does do. So now we've got our code that keeps track of where we're going on our racetrack. We now need to figure out when we've reached the end of our racetrack. And we've reached the end when neither of these 2 conditions are met, or neither of these 2 if statements are met. So if we don't run these 2 if statements, or if we don't pass these 2 if statements, that means we've reached the end of the track because there's nowhere else we can go. And how do we do that? This is where it gets slightly more complicated. So what we're going to do is we're going to say, if we found a valid track to go on, or a valid position to go on, we're going to break out of this initial for loop, because we've already found a valid thing. There's no point continuing this computation if we've already got our next answer. It's going to break out, which means we're going to be at this indentation level. And now what we're going to say is we're going to say, if we haven't broken out, so we're going to use the for else command, right? And else here is only run if we don't break out of this for loop. So if you don't break out of this for loop, then else is run. So if you don't break out, then we want to continue, sorry. like that. If we have broken out, so if this command has been run, and therefore if these commands have been run, then we want to break out of this for loop, right? Because again, we've already done the computation. There's no point continuing the for loop if we've already found the next position. And now we've got to do that all again for this outer for loop. So let's add another else and make sure that's the correct indentation level. And now we're going to say this code is only run if we haven't broken out of this outer for loop. And this is where it gets confusing because we only break out of that for loop if we found an answer. So if we haven't broken out of it, then we haven't found an answer, and therefore we are at the end of our track. And so the else here is not going to be continue, it's going to be break, and then the bit outside the else is going to be continue. But since this is the end of our while loop, we don't need to continue because it does that automatically. So what we're essentially doing is, we've got our infinite while loop, and we're breaking out of the while loop only once we haven't found a new valid coordinate to go to. And we keep track of whether we found a new valid coordinate to go to just by having this series of breaks and elses. And I'll show you an alternative way to do this at the end of the video in case this is a bit too confusing. Okay, so we basically reached the end of the track now. Now what we need to do, we need to print off the track where our hashtag ends. But bearing in mind, we also need to remove where it's begun. So where it's begun, we need to replace the hashtag with a 0. And so let's actually just do that at the start of the code. Let's take our track variable and let's replace the starting position, which is this, with a 0. But as you might have noticed, we're referring to a list, we're referring to a string, and you can't change something in a string. And so let's just convert that into a list right here. I think that should work well. Yep. And so now this is a nested list. It's a list of 6 lists instead of a list of 6 strings. It's a list of 6 lists. And we've changed our initial position to a 0. Now let's change our final position to a hashtag. So it's basically going to be the same code. Let's just copy that. And instead of a 0, we're going to turn that into a hashtag. And our very final thing to do is to print it off, which is usually the easiest part of the program. But in this case, it's difficult because we want to format our string, our track in a very specific way. And so let's go for every row in our track. We want to print out the row, but we want to print out the row not as a list, but as a string. So we can unpack the row. To unpack the row, we add an asterisk before the variable row. And so what this does is it will essentially print out, say we had, okay, let's say that's not one. So let's say this was our row that we're currently referencing. What this unpacking asterisk will do is it will print out this. So it prints out the elements of your list as a series of elements, basically, or string as a string, but it adds a space between each of your elements, which of course we don't want. So to change that, we can add this extra parameter in our print command called sep, which stands for separate. And we can just say the separator is going to be nothing. So our separator is going to be blank. So by default, it's a space, and that's why there were spaces. But if we change it to that, there are now not going to be any spaces between the elements of the list that are printed out. And so now if we run this, that code should hopefully work. Seems promising. Yep, that's a 10 out of 10. Okay. And now, as promised, I'm going to show you a different way of basically doing this whole shenanigan thing, which is when you want to exit you want to know when you need to exit the infinite while loop without having to deal with all of this random for else logic. And the way we can do that is by creating a flag. And so our flag is just an indicator of whether we found a new position or not. And so when we do find a new position, let's set our flag to 1, and by default it's 0. So when you find a new position, our flag is now 1. Therefore, we can check if our flag is equal to 1 or 0. So if flag is equal to 0, then we still haven't found a new position. And that means we can break here. And this code, again, does the same thing. Arguably, this method is easier, but it adds another variable. Whereas our method beforehand was pure logic, which is always cooler. But yeah, these are both effectively the same piece of code. And yeah, you see they both get a 10 out of 10.